Alright, here we are. We've done our final function. We figured out what the power n is for our function. It's 0.5. We rounded that value, which is a perfectly acceptable and encouraged thing to do. And now we have to figure out, well look, these a to the 0.5, these values have uncertainty because they came from a values which had uncertainty. So for this first one, what's the uncertainty in this 2.2 number? And then for this one, what's the uncertainty? That's what we're going to figure out next. I'm going to move my final function graph over for the time being. And first what I'm going to do is I'm going to find the percent uncertainty in the a values. Why am I going to find the percent uncertainty? Because when you take a value and you raise it to an exponent, the rule says multiply the exponent by the percentage uncertainty. In other words, once I have the percent uncertainty in a, I'm going to find the percent uncertainty in a to the 0.5. Let me highlight superscript. And the way I'm going to find this, like let's say the first value, this 5 years plus or minus 0.1, let's say the uncertainty comes to 2%, right? And I can express that as a percentage, 2%. Well, if it comes to 2%, I'm going to say equals, take my percentage and multiply by the exponent, because that's what the rule says, G7 times 0.5. So I'll multiply that 2% by the exponent of 0.5. That's how you propagate uncertainty through exponentiation, and that's how I get the percentage uncertainty. This would be 2. And then what I would do is I would find the actual absolute uncertainty in a to the 0.5 superscript. And let me center these. The way I'm going to find the absolute uncertainty is I take, well, what's my equation? The general rule is for any variable or measurement x, the percentage uncertainty is equal to the absolute uncertainty divided by the value of x. So if I have not x but a to the 0.5, whatever that value is, the percent uncertainty in a to the 0.5 is the absolute uncertainty in a to the 0.5 times a to the 0.5. So how can I find the absolute uncertainty? I multiply both sides by a to the 0.5. And what do I have? I have this. So the absolute uncertainty is simply the value of a to the 0.5. Oops. The value of a to the 0.5 times its percentage uncertainty. Do I know a to the 0.5? Do I know the percent uncertainty? Yes, I do. Here's the percent uncertainty, it's 1%, and here's the value of a to the 0.5. So right here, all I need to get the absolute, multiply the percent, star the value. Okay, and then I'm going to have to take this number, I'll have to round it to 1 sig fig, so I can just use the decimal button to decrease the decimal places, and that's how I'll do my rounding. But where does this value come from? I mean, I just guessed it was 2%. It turns out to be right, but how do I calculate, and then how do I calculate for all of these, the percent uncertainty in those measurements? Whoops. How do I calculate for all of these values of a, the percent uncertainty in those measurements? Here's what you do. The percent uncertainty in a is the absolute uncertainty divided by the measurement of a. It would be this. You take the absolute uncertainty in a divided by the actual measurement of a to get the percent. So, okay, where's the absolute uncertainty in a? Let's look back. The absolute uncertainty in a is just plus or minus 0.1 years. There it is. That's true for every single value of a. So I do 0.1 right here, 0.1, and then I have to divide by the value of a in this first row, which is just this. So I click on my 5. Then I hit enter. I've already made it a percentage by choosing the percentage here from the drop-down. So it's a percentage. I'm going to round it to the nearest whole number since it's 2 or bigger. And then I copy this down, I copy this down, and I copy this down. And now it's time to finish my rounding. Look at this. These values are all less than 2%. So what's our rounding rule? If it's under 2%, give it 2 sig figs. So now these need another sig fig. There we go. If it's under 2%, give it 2 sig figs. So these all need another sig fig. There we are. And these still need another sig fig. If you want to round these to just 0.09, 0.08, that would be perfectly reasonable to do. Okay, and likewise, if you want consistency in the rounding, you can round these to 2 decimal places if you want to be consistent. Okay, now these must have each just 1 sig fig. For these 0.01s, I want to make sure it's not 0.009, because if it's 0.009, I should leave it 0.009, not round up. So I add another decimal place by hitting this decimal, right? And then I take it away once I realize, okay, 0.01 is correct. Now that I have the absolute uncertainty in a to the 0.5, I come back to my final function graph. A to the 0.5, that's what's on the x-axis. Here it is. So I need to get these error bars. Let me take away the error bars first. And then I'm going to add them back on so they're nice and big. I right-click on the horizontal error bar. Let's see. I format. And I want custom values for the horizontal error bars. So I specify value, and I'm going to come over here. It's plus every a to the 0.5 value is plus or minus the number listed here. So I do plus that amount, or the negative error value, I erase the equals 1, I delete that, and then I choose again, I choose those uncertainties. So again, this is the horizontal, that's a to the 0.5. I have the absolute uncertainty in a to the 0.5, and here are those values. So I hit custom, and then positive error and negative error, both are the same thing because it's plus 0.04 or minus 0.04. And now it's added horizontal error bars to this graph here. Now it turns out they're too small to see. For my vertical error bars, again, it's a fixed value. The uncertainty in what's on my y-axis. My y-axis is diameter, so let me look at diameter. Oh yeah, the uncertainty is plus or minus 0.5. So let me just make those vertical error bars plus or minus a fixed value of 0.5, like this. I know it's vertical because I look up here. It shows that I'm editing the vertical error bars. So I hit enter. Wait, was it 0.5 or 0.05? It was 0.05. Okay. And I knew that because those looked way too big. So I fix it to be 0.05. I hit enter, and there we go. Alright, now the best fit line doesn't go through every error bar, but it's pretty good, pretty close for most of it. Okay. The next thing we're going to have to do is write out a function, a final function. Okay. So let me put this over here, split the screen for the moment. Alright, this is my final function graph. The first thing you do is you take that equation and you rewrite it. Y equals 0.2502x plus 0.0058. Now, there's something first I need to fix. Whoops. First, I realized that I had forgotten this. Absolute uncertainty in 0.5, a to the 0.5, this value has units. The units are years to the 0.5. Now you see what it's done? Everything is superscript. So let me highlight what I don't want to have as a superscript. I've highlighted it. You can highlight it here as well. All of this should not be superscript. And then I hit the font button, uncheck the box, OK, and there we go. I forgot to include units in my absolute uncertainty. The next thing that I forgot to do, these values are all rounded to the hundredths place. So my values of a to the 0.5 should likewise be rounded to the hundredths place. And that's how I know where these get rounded. I look at the uncertainty, which is only allowed to have one sig fig. Okay, all right, back to what we were looking at. You take your final function, there it is. You're going to do the same thing we've practiced and looked at in class. Replace the y in the equation with what's on the y-axis, diameter, which is d, 0.2502x plus 0.0058. Replace the x with what's on the x-axis, which is a to the 0.5. And then you add units, right? This is the slope of the graph. So its units are y units over x units. And in IB, we don't write over years to the 0.5. Instead, we write years to the negative 0.5. And I like putting parentheses so I can see things clearly. Here's the value of slope, and there are the units. I hit a space after doing the parentheses. Oh, wait, let's see. I hit a space after the parentheses to make it fill in. This value is the y-intercept, 0.0058. So it's a y value. It's where the line hits the y-axis. So the units here are meters. Units are never italicized. Variables are always italicized. That's generally the rule we're going to follow. And that is a big conclusion. If you think that this value is basically close enough to 0, you can just take it off. If you say, well, 0.0058, there's uncertainty in this amount. We're not going to calculate the uncertainty in the slope or the y-intercept. But you say, well, it's within, it's close enough to 0 that we can just consider it 0. That's a perfectly acceptable thing, too. You would introduce this. I've given you a sample introduction, but write your own when you introduce this. So you're going to include not only, you're going to include the graphs, Control-C, Control-V, and when you paste your graphs, this little control thing pops up, so you can make it just a picture. Make it a picture. That's probably the easiest way to paste. And you're pasting not just the final function graph, but the other two graphs, and you're also pasting the what you've used to make that graph. So include a table of values. So the final function is tree age. No, it's well, you know what you can do? Just copy this whole thing. No. You'll copy this in for your first graph. For whatever your first graph is, you'll copy this below. You can paste as a picture if you prefer. You can paste, try these different options. Paste, that's a nice one. Do that. Link and use destination styles. And then you can make that longer. Double click. See this icon? When I'm right between the two columns, if you double click, it'll automatically justify the width to fit the text. And then you'll have this for your second, Control-C. And then for the final graph, you can copy this, Control-C, paste it over here, get that icon, double click, and then for the final graph, you can just copy all of this over into Excel. All of those 4 or 5 columns. Okay, there you go.